and functions. So again, another vocabulary dump day. Nothing too new. A little bit of new information, a lot of review information, and a lot of changes in terminology. So we have two vocabulary terms. We have relation and we have function. We're going to start with relation. And yesterday we even talked a little bit about relations. Yesterday we talked about relationships. And a relationship is something and something else and how they affect each other. If I'm walking, my speed affects how far I travel. That's a relationship. So a relation is a relationship. A relation is a set of values, typically ordered pairs, that belong together.
I might want to put a little white out on your view. It looks like a V.
Just fix it, you know what it is.
That better?
Yeah, that's better.
A set of values, specifically ordered pairs,
Do they have to be ordered?
that belong together.
Yes.
We know that they belong together because they're written inside brackets. Those squiggly things that look like a face. If you can't make it perfectly, that's okay. I've been doing it for 13 years and these are still as good as I can make them. So for example, here's a relation. 1, 5. -2, 3. 4, -1. 0, 7. And -3, 1. And I know those are a relation because they're ordered pairs and they're written inside these brackets. If they were just listed and didn't have these brackets, I wouldn't be sure if they all belong together. But I know that these belong on the same graph together and they have some type of relationship. Just because of these squiggly brackets. So relation is a new vocabulary term, but it's still a concept that you already knew. You just have to assign the vocabulary term to this grouping. A new vocabulary term is the domain. Now, the vocabulary term domain is new, but the definition is not new. The domain in a relation is a list of X values from a relation. So I look at my relation and it may say list the domains. So I look at my relation and my domains are my X values. 1, -2, 4, 0, -3. Now we want to write them in numerical order. -3, -2, 0, 1, and 4. But that's not a new concept. You know how to identify X values. You just need to know that when we're talking about relations, the X values can also be called domains. Jacob.
So, I want to have, if you're equivalent fits, but
There is.
Is that our next vocabulary term?
It is the next vocabulary term.
Range.
Range. Now, range to you already has a definition. Range to you already is a maximum minus the minimum. However, when we're talking about relations, the range is the list of y values from a relation or in a relation. So I look and it's 5, 3, -1, 7, 1. But what do you think I want to do with them? Put them in order. -1, 1, 3, 5, 7. Is that right? Yeah. So do you feel confident that if given a relation, you can identify the domains and the ranges? Right? It's just the x and the y values. The next part that they may say to you, will say to you, is it a function? So a new vocabulary term, new concept totally. Function is new to us. A function is when each x value has only one y value. Each x value has only one y value. We can simplify that a little bit. The x values do not repeat. If you have 2 3s in your domain list, it's not a function. If each x value is different, yes, it's a function.
I have a question.
Yes.
So a function is basically the parentheses thing, x, y, and parentheses.
The function is a yes or no question. Each x value has to be different. You cannot repeat x values in a relation and have it be a function. A function must have all different x values. That idea is new. Everything else is pretty much new vocabulary terms. So is this relation a function? Yes or no? Yes. And if I said, why is it a function? You would say, each x value has one y value. The x's do not repeat. Another new concept today is something called function notation. And function notation is also known as an equation. It's a math problem. Have you solved equations before? Yeah. But a function notation must be written f of x equals, and then your problem. It must be written f of x because that f stands for function. And remember, a function is a series of x values in a relation that represents a relationship. So function notation is just a fancy term for equation. And the reason, the way you know it's a function is it's written f of x equals. And this stands for the function of x. So what you might see is it might say if y or x equals -3, find the f of x (2x plus 10). And that's read, if f of x equals 3, find the function of x in 2x plus 10. So what you do is you just substitute. Instead of f of x equals 2x plus 10, instead of x, what number am I going to substitute? -3. The function of -3, 2 times -3 plus 10. The function of -3, what's 2 times -3?
-6.
Plus 10. 4. The function of -3 is 4. So my ordered pair, -3, comma, 4. That's a relationship. When I put -3 into my problem, I get an answer of 4. Zach?
F of x is an equivalent of y, correct?
Correct. They are the same. Just one is considered linear and one is considered function notation. All right, 3 other things. New information. Let's go to old information. There are 3 other ways. Besides writing a list, there are 3 other ways you could write relations or functions. One way is a table. And when making a table out of a relation or a function, your x values must be in order. When you're creating a table, your x values must be in order. So if I'm looking at our first relation up here, I'm making a table out of that relation. What ordered pair is going to go first in that relation written at the top of your notes? And the relation at the top, which ordered pair is going to go first in our table? Cameron? -3, 1, because that's my first, smallest, least x value. -3, 1. What's my next x ordered pair? I already used this one, so what's my next ordered pair in my table from this relation? Gabby? -2, 3. What's my third ordered pair from this relation in my table? I've used -3, 1. I've used -2, 3. What comes next?
0.
0, 7. Then 1, 5. I'll have to squeeze it, you're right. And what's my last one? 4, negative 1. Is this new? No, you've created tables before. This is not a new concept. Looking at this, can you identify the domains? Yeah, it's super easy. Right here. Can you identify the ranges? Yes, but should you list them 1, 3, 7, 5, negative 1? No, you need to order them. So it's a little tricky because they're not in order. Second thing, second way that it may, or I guess third really, is a graph. So we've got a list of ordered pairs. You've got a table. Now we have a graph. And I can use my ordered pairs right from my table, correct? Or you can use your list of ordered pairs from up here. Doesn't matter. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, negative 3, 1. Negative 2, 3. 0, 7. 1, 5, 4, negative 1. All I did was take the ordered pairs from the relation, or take the ordered pairs from the table, either way, and put it into a graph. If you were just given the graph, could you identify the domains? Yeah, you just have to count. Is it a lot more work than other ways? Yeah, it is a lot more work to find your domains. But you can do it. Could you find your ranges? Yeah, you just have to count. Could you tell if it's a function? Can you tell if each x value has only one y value? Yeah, again, you'd have to count. But from a graph, you can also tell if it's a function, what the domain, what the range is, and if it's a function. The last one is for all of you visual learners out there. It's a mapping diagram. Mapping diagram kind of reminds me of in elementary school. Do you remember making input-output tables? You know, if you put in 7 and you get out 10, and you put in 8 and you get out 11, write the rule, right? They kind of remind me of those. So mapping diagrams, the x and y values must is spelled with a U, not an E, be in order. So a mapping diagram, you must have your x values and you must have your y values in order.
How do you not know how it's separated?
That's a good question. So let's look. Let's just copy from our table because our x values are already in order, correct? Negative 3, negative 2, 0, 1, 4. And then our y values, negative 1, 1, 3, 5, 7. Is that correct?
Yes.
And then how do we know? Jacob asks, how do you know what goes with what? Zach, what do?
Draw a line.
You draw an arrow or a line. 3 goes with 1, or negative 3 goes with 1. Negative 2 goes with 3. 0 goes with 7. 1 goes with 5. And 4 goes with negative 1. Now, if you had a number that had two answers, like you had -2 and then another -2, you'd only write one of them. So you'd reduce, you only write duplicates one time. And then you can draw 2 arrows to the same number, that's fine. Or 2 arrows to different numbers. Looking at the mapping diagram, can you determine the domains? Can you determine the ranges? Can you say if yes or no it's a function? Yeah.